Okay, this video is going to be about speed, distance and time. It's part of our safe driving part of our course. Now, this should be a fairly easy section because we have done quite a lot of work on the speed, distance, time, and we've been working a lot on rates. So let's have a look at it. The first thing I want you to have a look at is just to understand that the common speed limits in New South Wales. You can see school zones 40 kilometres per hour. Residential areas is 50 kilometres per hour. On the normal city streets, 60 kilometres per hour. A highway is 100, and the motorway is generally 110. So that's just something you should be kind of familiar with. The other thing you should be familiar with is average speed. The average speed formula, speed equals distance over time. Well, once you know that, you should know that you can rearrange this formula and you can get distance equals speed times time. Or the other way you can rearrange the formula is to make time the subject. Time equals distance over speed. Now, once you know those formulas, you can either learn all three. I think it's much easier just to learn one because you're all good enough to be able to turn this around. Once we know that, we can very easily do any speed question whatsoever. So let's have a look at our first example. Bella left home at 6 a.m. to travel from Sydney to Brisbane at a distance of 1,027 kilometres. She stopped for meal breaks and fuel and arrived in Brisbane at 8:30 p.m. And the first part of the question says, what was her average speed? So, average speed, what do we know? What do we need? Well, we need distance. And we were told she travelled a distance of 1,027 kilometres. And we need to know how long that took her. Now, we're not exactly told how much time, but we can work it out. Because she left home at 6 a.m. and then she got to Brisbane at 8:30 p.m. So if we think about from 6 a.m. until 8:30 p.m, that is 14 and a half hours. I'm just going to write that as 14.5 hours. So now we can use our formula. Speed equals distance over time. So we know our distance is 1,027 and time is 14.5. And we plug that into our calculator. We get 70.825 kilometres per hour. And we want it to the nearest kilometre, so that must be 71 kilometres per hour. Nice and easy. So part B then says, how far to the nearest kilometre could she travel at this speed in 50 minutes? So what do we know? Well, the speed we know, we just worked it out, is 71 kilometres per hour. And our time, we're told, is 50 minutes. But we really should change this into hours because my speed is in kilometres per hour. So to change my time into hours, I'm going to divide it by 60. So now my time is in hours. So using the rearrangement of my formula, distance equals speed times time, we can now plug in the numbers that we have. And we can see what we get. I'll have to move the page up a bit. Is we get, I think it's 59.166. So it's 59 kilometres, which is to the nearest kilometre. So the last part of the question says, how long in hours and minutes would it take her to drive 864 kilometres at this speed? Okay, so we're trying to find, for part C, how long. So we're going to be looking for time. So my rearranged formula when I talk about time is time equals distance over speed. So the distance we're told is 864 kilometres. And my speed, well, that's the speed that I've worked out in part A, which is 71. And if we place that into our calculator, we get 12.169. Now this is in hours, and as we've talked about before, we don't leave our answer just like this. It would probably be best to change that into hours and minutes. So we're going to use once again our bubble key on our calculators, and when we do that we get 12 hours and 10 minutes. So hopefully you understand this now. There is classwork and there are some extra worksheets to go along with this topic that you can now complete.